Hello guys, my name is Craig and welcome to Peri Solutions. In today's video, we're going to talk about infinite geometric progressions. But before we start, please make sure that if you're new to my channel, you hit the subscribe button and turn on the notification bell so that you don't miss out on any new videos. So to start off, we know that for a geometric progressions, let's say for a geometric progression, a plus ar plus ar squared n plus ar to the power of n minus 1. We know that the sum of n terms is given by a times 1 minus r to the power of n over 1 minus r, for which the modulus of r is less than 1. Right? So now we want to study what happens when n increases. Right? So when n increases, we notice that r to the power of n approaches 0. Right? So when n increases, r to the power of n approaches 0, such that we are saying when n approaches infinite, r minus 1 approaches 0, then the sum to infinite will be given by a 1 minus 0 over 1 minus r, which is just a over 1 minus r, for which the modulus of r should be less than 1. So this is what we call the sum to infinite, right? So therefore we're simply saying the sum to infinity is given by a over 1 minus r, for which the modulus of r is less than 1. So that's the formula that we're going to use, which applies to solve these questions. So allow me to erase this. So what's important to take note of is that we say sum to infinity is given by a over 1 minus r, for which the modulus of r is less than 1. So now for number 1, the sum of the first four terms of a GP are 3 minus 1, 1 over 3, and minus 1 over 9. Find the sum to infinity. So from the formula, we need a, which is the first term, and we need r, which is the common difference, the common ratio. So first term we have it as 3 already. Now we need the common ratio, which we shall say, this for number 1. So saying r is given by second term over first term. So this is minus 1 over 3. So this is the common ratio, such that the sum to infinity shall simply be a, which is 3 over 1 minus r, minus 1 over 3. This will be 3 over this, gives us a plus, 1 plus a third, that will give us 4 over 3, and 3 times 3 over 4, that will give us 9 over 4. So 9 over 4 will be the sum to infinity for number 1. Then moving on to number 2, a GP is a common ratio of 3 over 4, and a sum to infinity of 92. Question says, find the first term. First term, we know this is our a. So if we make a the subject of the formula, a would be equal to sum to infinity multiplied by 1 minus r, which is 92 times 1 minus 3 over 4, which is 92 times 1 over 4, and that will give us what? 2, this will give us 23. So 23 will be the first term that we have. And now let's move on to number 3. Okay, moving on to number 3, we're told that a GP, geometric progression, is a sum to infinity of minus 30. The first term of the GP is minus 9. Find the common ratio. So now we need to find r. So if you make r subject of the formula, say 1 minus r is equal to a over the sum to infinity, such that r would be equal to 1 minus a over the sum to infinity. Right? So we're saying 1 minus a, the first term is minus 9. So we're saying minus 9 over sum to infinity is minus 30. And this will be 1 minus 9 over 30, which is 21 over 30. So 21 over 30 is the common ratio, which of course we can simplify to 7 over 10. Right, like that. This for number 3. And now moving on to number 4. Number 4 says the first four terms of a GP are 1, then x over x plus 1, then x squared over x plus 1 squared, then x cubed over x plus 1 cubed. Question says find the sum to infinity for this geometric progression. So we need the first term a and the common ratio r. Common ratio r, if we say second term over first term, our common ratio is from before. Our common ratio is to just be x over x plus 1, such that the sum to infinity would be a, which is 1 over 1 minus x over x plus 1, right? And if we make this one fraction, a single fraction, this will be over 1, so 1 over x plus 1, then x plus 1 minus x, like this. This will be 1 over x plus 1, which when we invert, will simply give us x plus 1. So this will be the sum to infinity for number 4. Then now moving on to number 5. Okay, moving on to number 5. The sum of the first two terms of a GP is 10. So the first two terms, we've got a plus ar, and this equal to 10, right? And then the sum to infinity of the GP is 18. So a over 1 minus r is equal to 18. And then our question says, work out the two possible values of the common ratio. So now we've got these two equations. We'll say 1, then equation 2. So from equation 1, if we can factor out a, we've got 1 plus r being equal to 10. And from equation 2, we've got a being equal to 18 times 1 minus r, like this. Yes, so we've got these two now. And as we can see that we've got a already here. So we can say, in place of a, we put this, such that it's 18 times 1 minus r times 1 plus r to give us a 10. And then if we were to divide both sides by 18, and this difference of two squares, that would be 1 minus r squared is equal to 10 over 18, right? Then r squared would be 1 minus 10 over 18 here, and this will be equal to 8 over 18, right? Then r squared will be, factoring out 2, 4 over 9. R will be plus or minus square root of 4 over 9, which is plus or minus 2 over 3. So r is equal to 2 over 3 or minus 2 over 3. These are the two possible values of r that we get, right? And then now moving on to number 6. So I shall erase this part here. Right, moving on to number 6. Number 6 says, all the terms of a GP are positive. The sum of the first two terms is 100. So for number 6, we're saying a plus ar is equal to 100. And the sum to infinity is 180. So a over 1 minus r is equal to 180. Question says find the first term and the common ratio. So now if you do the same thing, this is equation 1, this is equation 2. If from equation 1, if you factor out a, we've got 1 plus r being equal to 100, right? And from equation 2, we've got a being equal to 180 times 1 minus r. Such that in place of a, we make the substitution by 180 times 1 minus r. So 180 times 1 minus r times 1 plus r should give us 100. And if we divide both sides by 180, we'll simply say 1 minus r, this difference of two squares, so 1 minus r squared is equal to 100 over 180, which is 10 over 18. Then r squared would be 1 minus 10 over 18 to give us 8 over 18, such that r would be square root of 8 over 18, which is plus or minus 2 over 3. But now it is highlighted in the question that all terms of a GP are positive. right? So now it definitely means that for the common ratio, it should be positive. So therefore, we are picking the value of r, that is 2 over 3. So to find a, we're simply saying, using this, a is 180 times 1 minus 2 over 3, which is 180 times 1 over 3, which will give us a 60. So the first term a is 60, and the common ratio r is 2 over 3. Right? These are the two solutions that we need for number 6. So this was looking at infinite geometric progressions. And please feel free to leave a comment, drop a like, and don't forget to subscribe. Thank you.